On October 14th, 1943, 291 B-17 flying fortresses climbed through the frozen air over occupied Europe, carrying nearly 3,000 men toward the ball-bearing factories at Schweinfurt, Germany. This was the second time the 8th Air Force had sent bombers to Schweinfurt. The first raid, 2 months earlier, had been a bloodbath. 36 bombers shot down, hundreds of men killed or captured. The survivors had returned with stories of fighter attacks so intense that some crews ran out of ammunition before reaching the target. They spoke of German fighters queuing up in the distance like cars waiting at a toll booth, taking turns making firing passes at the American formations. Schweinfurt produced ball bearings. Ball bearings were essential components in virtually every piece of military equipment Germany manufactured. Tanks needed them. Aircraft needed them. Submarines needed them. American planners believed that destroying the ball-bearing factories would cripple German war production. The target was worth any cost. Now they were going back. The crews knew what awaited them. They had seen the empty bunks in their barracks after the first raid. They had attended memorial services for men who had been alive and joking at breakfast and were dead by dinner. They knew the odds. And they climbed into their bombers anyway. At 25,000 feet, the temperature outside those bombers had dropped to minus 50 degrees Fahrenheit. Inside the aircraft, it was not much warmer. The B-17 had no pressurization, no heating system. The thin aluminum fuselage conducted cold directly into the crew compartments like a refrigerator wall. Frost formed on the inside of windows. Breath froze on oxygen masks. Metal surfaces became so cold that touching them with bare skin meant instant frostbite. The waist gunners had it worst. They stood at open windows on either side of the aircraft, manning 50 caliber machine guns. That required them to lean into a 200-mile-per-hour slipstream of Arctic air. Wind chill at those speeds, and temperatures dropped the effective temperature to levels beyond anything the human body could endure. Even with electrically heated suits and multiple layers of insulated clothing, these men were fighting against conditions that would freeze exposed flesh in less than 60 seconds. Every man aboard those bombers wore an electrically heated flight suit, a one-piece coverall with heating wires sewn into the fabric. The suits plugged into the aircraft electrical system and were supposed to keep crews alive at extreme altitude. Supposed to, but the suits had a fatal design flaw that no one had caught during testing. And that morning over Europe, dozens of those suits were failing. Wires were breaking inside the fabric. Heating circuits were dying. Men who had been warm one moment found themselves suddenly exposed to killing cold with no protection and no way to fix the problem. The German fighters and anti-aircraft guns would devastate the formation that day. 60 bombers shot down, more than 100 others damaged, many so badly they would never fly again. Over 600 men killed, wounded, or captured. The mission would become known as Black Thursday, one of the darkest days in American military aviation history. But what the survivors did not yet understand, what the Army Air Force's leadership was only beginning to grasp, was that the cold itself was claiming even more victims than German guns, not as dramatically, not as visibly, but just as permanently. In the 14 months ending in December 1943, 1,634 men would be removed from flying duty because of cold injuries sustained on operational missions. During the same period, 1,207 men would be removed because of wounds from enemy action. The cold was killing more American airmen than the Luftwaffe. This is the story of how America tried to beat German fighters at high altitude and accidentally froze its own pilots to death. It is the story of bureaucratic failure and individual heroism, of engineers who never experienced combat designing equipment for men who would die using it, of a surgeon who had served in the trenches of World War I and refused to accept that good men should keep dying from preventable causes. And it is the story of how the lessons learned in frozen agony over Germany would reshape military aviation for generations to come. The problem began with a fundamental miscalculation about the nature of aerial combat over Europe. When Boeing designed the B-17 Flying Fortress in the mid-1930s, engineers in sunny California envisioned a strategic weapon that would fly higher than enemy fighters could effectively reach. The bomber's service ceiling exceeded 30,000 feet. At that altitude, anti-aircraft guns lost accuracy because the time of flight for their shells allowed bombers to move unpredictably. Fighter planes struggled to climb high enough to intercept, and those that did find their engines starved for oxygen, their controls sluggish in the thin air. The high-altitude doctrine made tactical sense. Flying above the threat meant surviving to bomb another day. American war planners built their entire strategy around this concept. Formations of heavy bombers would fly in tight defensive boxes, their overlapping field of machine gun fire creating a wall of lead that enemy fighters could not penetrate. They would bomb from above the worst of the defenses and return home largely intact. The theory was elegant. The reality was catastrophic. The designers had never experienced what their crews would face. They had calculated the bomber's performance at altitude, but had not fully considered what altitude would do to the men inside. At 30,000 feet, air temperature drops to 60 degrees below Nero Fahrenheit. At 25,000 feet, where most combat occurred, temperatures averaged 40 to 50 below. Human flesh exposed to that cold freezes in less than 60 seconds. Bare metal becomes so cold that contact means instant frostbite. Breath freezes before it leaves the oxygen mask. The B-17 carried a crew of 10 men distributed throughout an unheated, unpressurized fuselage. The pilot and co-pilot sat in the cockpit at the front, their positions relatively protected but still exposed to bitter cold. The bombardier and navigator occupied the nose compartment below them, surrounded by plexiglass that offered spectacular visibility, but almost no insulation. The flight engineer manned the top turret behind the cockpit. The radio operator sat at his station in the midsection. 2 waist gunners stood at open windows on either side of the fuselage. The ball turret gunner crouched in a spherical turret beneath the aircraft. The tail gunner sat isolated in a cramped compartment at the extreme rear. Every position was cold, but some were killing cold. The waist gun positions were exposed to a 200-mile-per-hour slipstream through open windows. The original design provided no covering for these windows because gunners needed maximum freedom of movement to track attacking fighters. When enemy aircraft came in on beam attacks, waist gunners leaned out into that Arctic blast, pivoting their heavy weapons to follow targets that were closing at combined speeds of over 500 miles per hour. No amount of clothing could protect against that kind of exposure. One chill calculations. At 200 miles per hour in minus 50-degree air produce effective temperatures far below anything humans can survive for extended periods. Even brief exposure meant frostbite. Extended exposure meant permanent injury. The Bohr turret was worse in a different way. Manufactured by the Sperry Corporation, it was a marvel of compact engineering that had become a nightmare of exposure. The spherical turret was roughly 4 feet in diameter, just large enough to contain a man in the fetal position along with 250 caliber machine guns, ammunition feeds, a reflector sight, and the mechanical systems that allowed the turret to rotate in any direction. There was no room for a parachute inside the turret. There was no room for extra clothing. There was barely room for the gunner. Only the smallest crew members were assigned to this position. Regulations generally limited ball turret gunners to men under 5 feet 6 inches tall and 150 pounds in weight. The turret was surrounded by plexiglass and aluminum that offered no insulation whatsoever. Cold radiated through every surface. The gunner sat with his knees drawn up to his chest, his hands on control. Handles that became so cold they could freeze through gloves. His feet rested on pedals that became blocks of ice. His back pressed against the turret shell, which conducted cold directly into his body. If something went wrong with his heating equipment, the ball turret gunner had no options. He could not easily leave his position because the turret had to be rotated to a specific orientation for him to climb out, and that rotation required electrical power. If battle damage cut the power, or if the turret mechanism jammed, the gunner was trapped. And if his heating suit failed while he was trapped, he would freeze. Most ball turret gunners whose suits failed chose to stay in the turret. They understood that leaving would endanger the aircraft and crew. German fighters had learned to attack from below because it was a vulnerable angle. A fighter coming up from underneath could rake the bomber with fire before the top turret or waist guns could respond. The ball turret gunner was often the only defense against these attacks. Abandoning the turret meant abandoning his crewmates to that threat. So they stayed. They kept their hands on the control handles, tracking the sky below for enemy fighters even as the cold crept through their bodies. The temperature in the turret dropped steadily as the aircraft climbed. At 22,000 feet, it was 30 below zero. At 25,000 feet, it was 40 below. The cold radiated through the plexiglass dome, through the aluminum structure, through the thin leather of their flight gloves. Their fingers went numb first, then their hands, then their forearms. The numbness crept up their arms, like water rising in a bathtub, steady and inexorable. But they kept their hands on the controls. They kept watching for fighters. They kept doing their jobs until the aircraft landed and someone came to help them out of the turret. The flight surgeons who treated these men after missions sometimes had to cut the gloves off, their hands with surgical scissors because frozen fingers could not flex to remove them. The flesh underneath was white and hard, frozen solid. Many lost fingers. Some lost entire hands. All of them had done their duty until the very end. The tail gunner sat in complete isolation from the rest of the crew, separated from them by the length of the fuselage and surrounded by cold that flowed around the tail surfaces and into his compartment. He could communicate only by interphone. If his oxygen system failed or his heating suit died, no one could reach him to help. He would simply freeze alone, while his crewmates continued the mission unaware of his situation until they landed and found him. The first bombers of the 8th Air Force arrived in England in the summer of 1942, ready to prove that daylight precision bombing could win the war. What they discovered instead was that their own aircraft were killing crews before the Germans had a chance. Colonel Malcolm Grow had seen combat before, and he understood what it did to men and to organization. As a young surgeon in 1915, he had traveled to Tsarist Russia and volunteered to serve with the Russian army on the Eastern Front. For 2 years, he had operated on wounded soldiers while German artillery shells exploded around his field hospital. He had worked in conditions that would have seemed impossible to American medical professionals of the era, improvising surgical techniques and treatment protocols while under fire. The Russians had recognized his courage and skill. He earned the Order of St. George for gallantry under fire, one of the highest military decorations Imperial Russia could bestow on a foreign officer. He also received the Order of St. Stanislaus for his surgical work. His 1918 memoir, Surgeon Grow, An American in the Russian Fighting, documented these extraordinary experiences and established him as one of the few American military medical officers with extensive frontline combat experience. In 1917, after the Russian Revolution made his position untenable, Grow returned to the United States and joined the army. He spent the interwar years building expertise in a new field that barely existed when he had left for Russia, aviation medicine. He earned his aviation medicine certificate in 1928 and helped establish the Aero Medical Laboratory at Wright-Patterson in Ohio. By the time the United States entered World War II, Grow was one of the most experienced aviation medicine specialists in the military, combining practical combat experience with deep knowledge of the unique physiological challenges of flight. General Carl Spaatz was building the 8th Air Force in England and needed a surgeon who understood both combat and aviation, someone who could handle mass casualties, someone who knew how to operate under wartime conditions, someone who could improvise solutions when standard procedures failed. Malcolm Grow was the obvious choice. Grow arrived in England in 1942 and immediately began studying the unique medical challenges of high-altitude bombing operations. The problems were unlike anything American military medicine had faced before. Ground combat produced wounds from bullets and shell fragments, injuries that medical professionals understood and knew how to treat. But high-altitude bombing produced something different. It produced cold injuries. The first frostbite cases came back from early missions over occupied France. Waist gunners with blackened fingers. Tail gunners whose ears had turned white and hard and numb. Ball turret operators who could not feel their feet when they climbed out of their turrets after landing. Men who had not been touched by enemy fire, but who were just as badly injured as if they had been. The injuries were severe enough to ground experienced crews, men the 8th Air Force desperately needed. Training a bomber crew took months. Combat experience took even longer to acquire. A pilot might have hundreds of hours of flight time, but combat flying was different from training. A gunner might have practiced on ranges, but shooting at towed targets was nothing like shooting at fighters that were shooting back. Every man lost to frostbite was a gap in capability that could not easily be filled. Grow studied the casualty reports with growing alarm. The pattern was unmistakable. Men were getting frostbite despite wearing the protective gear the Army had issued them. They were following procedures. They were using their equipment correctly, and they were still freezing. The equipment was supposed to work. The specifications said it would protect against high-altitude cold. The manufacturers had tested it. The procurement officers had approved it. But the specifications were wrong. The electrically heated flight suit was supposed to be the solution to high-altitude cold. The concept dated back to 1918, when the Army Air Corps first experimented with electric heating for aviators flying open cockpit biplanes. Development continued through the 1920s and 30s, driven by the increasing altitude capabilities of new aircraft. By 1941, the standard heated suit was the F-1, manufactured exclusively by General Electric and standardized on April 4th of that year. The F-1 was a one-piece coverall made of felted woven wool with heated wires sewn throughout the fabric in a blanket-style pattern. The suit plugged into the aircraft 24-volt electrical system through a 2-pin connector. Power flowed through the wires, generating heat through electrical resistance. The concept was the same as an electric blanket, adapted for aviation use. Pilots and crew called it the Blue Bunny because of its distinctive light blue color. When functioning properly, it could keep a man comfortable at 30 degrees below zero. Priority for the suits went to tail and ball turret gunners who occupied the coldest position, with waist gunners next in line, if sufficient electrical capacity was available. The B-17 was the only bomber that used a 24-volt electrical system at the time, so only B-17 crews could use the Blue Bunny suits. The concept was sound. Electrical heating could generate warmth without requiring heavy insulation that would restrict movement. A man wearing a properly functioning heated suit could operate his weapon systems without the bulk of Arctic survival gear. He could track targets smoothly. He could manipulate controls precisely. He could fight effectively even at extreme altitude. The execution was catastrophic. The F-1 suit had a fatal design flaw that testing in the American Southwest had not revealed. The heating wires were connected in series, like old-fashioned Christmas lights. Electric current flowed through every wire in sequence from one end of the circuit to the other. If every connection was intact, the suit worked perfectly. Current flowed smoothly through the entire system, heating every portion of the fabric evenly. But if one wire broke anywhere in the circuit, the entire system failed. No current could flow past the break. The suit went cold completely and instantly, with no warning and no way to restore function. One moment a man was warm. The next moment he was exposed to killing cold with no protection. The wires broke constantly. The felted wool fabric shifted during movement, stressing the wires sewn into it. Gunners twisted and turned to track enemy fighters. They crouched and stretched to clear jammed weapons. They climbed in and out of cramped positions. They moved in all the ways that combat required them to move, and every motion stressed the fragile wiring sewn into their suits. The testing in the American Southwest had not caught this problem because the testing had not replicated combat conditions. Men wearing the suits in test environments moved carefully and deliberately. They did not twist and dive and scramble the way men did when German fighters were shooting at them. The wires held up to careful movement. They did not hold up to combat. A man would simply realize, at 25,000 feet over enemy territory with Focke-Wulf, 190s making firing passes at his aircraft, that his suit had stopped working. The warmth would disappear. The cold would begin seeping through his flight gear. He had minutes, perhaps 15 or 20 if he was lucky, before Frostbite began destroying his hands. And there was nothing he could do about it. He could not diagnose the problem. He could not fix the break. He could not even identify where in the circuit the wire had failed. The Army's investigation, conducted in March 1943, documented the scope of the disaster. Electrically heated garment failures were responsible for approximately 3/4 of frostbite casualties caused by equipment malfunction. The suits were failing faster than they could be replaced, faster than crews could adapt, faster than the supply chain could deliver new equipment. The Blue Bunny was supposed to save lives. Instead, it was creating casualties. Colonel Grow compiled statistics that told a story the Army Air Force's leadership did not want to hear. In the 14-month period ending in December 1943, Frostbite was removing more men from flying duty than German fighters and anti-aircraft guns combined. The cold was a more effective weapon than the Luftwaffe. A third of all frostbite casualties required hospitalization. Many of those men would not return to duty for months. Some would never return at all. You cannot grow back amputated fingers. Frostbitten feet that have lost circulation do not heal quickly or completely. Men who had survived German fighters and flak were being permanently disabled by their own equipment. The 8th Air Force was bleeding trained aircrew faster than replacements could be trained and shipped across the Atlantic. The training pipeline could not keep pace with losses. Experience was being drained from the squadrons every time a veteran gunner lost fingers to the cold, and the enemy causing most of the damage was not flying fighter aircraft, or manning anti-aircraft batteries. The enemy was the temperature at altitude, the failed heating suits, the open windows in the waist gun positions. The inadequate equipment and training that no one had anticipated would become a crisis. Grow presented his findings to commanding officers. The response was a mixture of frustration, denial, and bureaucratic paralysis. The heating suits were supposed to work. The specifications said they would function at high altitude. The manufacturer claimed they had been thoroughly tested. Procurement officers who had purchased thousands of these suits insisted they met all requirements, but specifications meant nothing when wires were breaking inside the suits. Manufacturer claims meant nothing when men were losing fingers. Procurement paperwork meant nothing when the Blue Bunny suits failed mission after mission. Grow pushed harder. He requested resources to study the problem systematically. He asked for authority to develop alternative solutions. He wanted engineering support to redesign the heating systems. He needed manufacturing capacity to produce improved equipment once designs were finalized. The bureaucracy moved slowly. Requisitions sat on desks waiting for signatures. Approval chains stretched across the Atlantic to Washington. Officers who had never flown a combat mission debated the necessity of expenditures. Paperwork disappeared into files and was forgotten. Meanwhile, men kept freezing. Wind blast was the single largest cause of high-altitude frostbite, responsible for 39% of all cases in the 14-month period, ending December 1943. By 1944, that proportion had risen to nearly 55%. The problem was simple physics. Air moving at 200 miles per hour strips heat from the human body faster than any heating system can replace it. Even a perfectly functioning heated suit could not overcome that heat loss when a waist gunner was leaning into the slipstream tracking an attacking fighter. Clearing jammed guns created another deadly problem. A 50 caliber machine gun could jam at any moment during combat. The gunner had to clear the jam or his weapon was useless. Clearing the jam meant working with the weapon's charging handle, a metal lever that had to be gripped firmly and pulled hard. Training manuals said this could be done while wearing the heavy leather flight gloves issued to crews. The training manuals were wrong. The gloves were too bulky for precise manipulation. They had been designed for warmth, not dexterity. A man wearing them could grip a gun handle and press a trigger, but he could not work the fine mechanisms needed to clear a malfunction. Gunners across the 8th Air Force discovered this in combat, when their guns jammed, and enemy fighters were attacking, and they had seconds to get their weapons working again. They did what they had to do. They pulled off their gloves. They gripped frozen metal with bare fingers. They cleared the jams. They saved their aircraft and their crewmates, and they lost fingers. The flesh froze on contact with metal that had been chilled to 60 degrees below zero. 15 seconds of exposure was enough to cause permanent damage. 30 seconds could mean amputation. Casualty reports noted that these men had violated proper procedure by removing their gloves. Regulations clearly stated that gun malfunctions should be cleared with gloves on. The bureaucracy blamed the men, but the regulations did not work. Everyone knew they did not work. Everyone who had actually flown combat knew that the choice was between losing fingers and losing your aircraft. The men did what they had to do because the alternative was dying. Ground crews watched their bombers return from missions with injured men aboard. They saw frostbite casualties carried off to ambulances. They heard the stories in mess halls and barracks. They knew something was terribly wrong. Master Sergeant Earl Southwick was a crew chief with the 398th Bomb Group, 603rd Squadron. His job was keeping his assigned B-17 flying no matter what condition it returned in, no matter what damage the Germans had done, no matter what systems had failed. Southwick worked long days in the cold and rain of an English winter. He patched battle damage with sheet metal and rivets. He replaced engines that had been shot out over Germany. He fixed hydraulic lines and electrical systems and oxygen regulators and 1,000 other components that could fail under the stress of combat. He understood the difference between official specifications and operational reality. Specifications said certain repairs required depot-level maintenance, meaning the aircraft had to be taken out of service and sent to a rear area facility. Specifications said certain modifications needed engineering approval from the manufacturer, meaning paperwork that would take weeks or months to process. But depot-level maintenance meant an aircraft was unavailable for combat for extended periods. Engineering approval meant paperwork that disappeared into bureaucratic black holes and never returned. The 8th Air Force needed every bomber it could put in the air. There was no time for proper channels. Southwick's assistant, Dallas Best, later wrote about those days. Had this kind of repair been made stateside, he said, I could have been court-martialed. But this was a different time and place. We had to do what had to be done to keep the planes in the air. The three-man ground crew of Southwick, Best, and Fred Whitman, maintained their B-17 so well that not one of their aircraft ever turned back from a mission because of mechanical problems. Southwick received the Bronze Star for this achievement. Ground crews improvised throughout the theater. They fabricated parts that were not available through supply channels. They performed repairs that regulations said only depot facilities could attempt. They modified aircraft to solve problems that original designers had never anticipated. The same spirit of improvisation drove efforts to address frostbite at the squadron level. Mechanics experimented with additional insulation for gun positions. They rigged extra electrical outlets for heated equipment. They wrapped heating elements in protective coverings to reduce wire breakage, but field expedients could not overcome systemic failure. The heating suits were designed wrong. The waste gun windows were open to the slipstream. The entire concept of operating in extreme cold had been inadequately considered. Individual initiative could not overcome systemic failure. The 8th Air Force needed solutions that came from the top down, developed by engineers and implemented across the entire force. Colonel Grow understood that the frostbite crisis required systematic response. Individual courage and improvisation could not overcome flawed equipment and inadequate training. The Army Air Forces needed new solutions developed by experts and deployed at scale. He began working on multiple fronts simultaneously. Better suits that would not fail, better training so crews understood the dangers, better protective equipment to address specific vulnerabilities, modified aircraft designs that would reduce crew exposure to the killing cold. The heated suit problem was the most urgent. Grow's investigation had identified the core flaw in the F1 design. Wiring the heating elements in series meant that a single break anywhere in the circuit killed the entire suit. The solution was obvious to anyone who understood basic electrical engineering. Wire the elements in parallel. In a parallel circuit, each heating element operates independently. Electric current flows through multiple paths simultaneously. If one wire breaks, current simply flows through the remaining paths. A man might lose heat to one part of his body, but he would not lose heat everywhere at once. The parallel design also allowed for redundancy. If the suit had two independent circuits, a break in one would still leave 50% of the heating capacity functional. A man with half his suit working could survive much longer than a man with no heat at all. Grope pushed the requirements through the procurement system. General Electric developed a new suit based on the parallel wiring principle. The F-2 electrically heated flying suit was standardized in August 1943. The new suit was fundamentally different from the Blue Bunny. Instead of a one-piece coverall, it consisted of 4 main pieces: an electrically heated jacket, electrically heated trousers, an unheated outer jacket, unheated outer trousers. The modular design allowed crews to replace individual components if one piece failed, rather than discarding an entire suit. The heating elements used more flexible wiring that resisted breakage. The connections between components were more robust, and critically, the wiring was connected in parallel rather than in series. Without electrical current, the F-2 suit was comfortable down to 32 degrees Fahrenheit. With current flowing through the heating elements, it could maintain comfort at 30 degrees below zero. The suit also included connections for heated goggles and oxygen mask heaters, addressing other cold-related problems that had emerged during operation. The F-2 variant added thermostats in February 1944, allowing crews to control the heat level instead of running at full power constantly. Crews had complained that original heating suits ran too hot in some conditions, causing sweating that then led to chill when the moisture froze. The thermostatic control solved this problem. The F-3 suit, introduced in the spring of 1944, extended the comfort range to minus 60 degrees Fahrenheit. It improved the electrical controls and fittings and enhanced the parallel wiring system so that even with multiple failures, the suit would continue providing some heat. But developing new suits was only part of the solution. Manufacturing them took time. Distributing them across the theater took more time. Training crews in their proper use took still more time. While improved equipment worked its way through the supply chain, Men continued freezing in the skies over Germany. The second major improvement addressed the wind blast problem. Grove's investigation had documented that wind blast through the open waist gun windows was the single largest cause of frostbite. Waist gunners were suffering because they stood at open windows exposed to 200-mile-per-hour Arctic wind. Wind chill at those speeds and temperatures was beyond anything the human body could endure for extended periods. No heating suit could compensate for that kind of exposure. No amount of insulated clothing could prevent frostbite when Arctic wind was blasting directly on exposed skin. The only real solution was to block the wind. The B-17G model began production in July 1943, following its first flight in May. The new variant entered combat service with the 8th Air Force in the fall of that year. The G model featured enclosed waist gun windows. The guns mounted through openings in plexiglass panels that blocked the wind, while still allowing the weapons to traverse and track targets. The new windows dramatically reduced frostbite among waist gunners. Men who had been losing fingers to wind blast exposure could now operate their weapons in relative comfort. The cold was still present, but it was manageable cold, the kind that heated suits and insulated clothing could handle. The G model also staggered the waist gun positions, placing the left gunner slightly forward of the right gunner. This gave both men more room to move without bumping into each other, reducing the tangling of oxygen lines and heated suit cables that had contributed to equipment failures. Colonel Grove pushed for additional innovations beyond suits and windows. He studied the casualty reports and identified specific failure modes that were causing injuries. For each problem, he developed a targeted solution. He designed warm, light, flexible gloves that did not have to be removed to clear jammed guns. The new gloves used thinner, more flexible materials that allowed precise finger movements while still providing insulation. Crews were trained that their hands would be frostbitten if they removed their gloves, and it was demonstrated that guns could usually be cleared just as readily with gloved hands as with bare hands if the gloves were properly designed. He created wind and fire-resistant face and neck protectors to address the frostbite. Injuries that had shifted to these areas as hand injuries declined. He designed electrically heated blankets for wounded men whose heated suits had to be cut away to treat injuries if the heat system of an aircraft was destroyed by enemy action, or if a wounded man's suit had to be removed. These blankets could provide warmth during the flight home. In July 1943, Grove received the Legion of Merit for developing body armor to protect combat crews. His analysis of wound reports had shown that nearly 70% of combat wounds were caused by low-velocity missiles, primarily shrapnel from anti-aircraft shells that had fragmented nearby. He designed a light body armor made of overlapping steel plates that could stop these low-velocity fragments. The armor saved many lives and improved morale. In May 1944, Grove was awarded the Distinguished Service Medal for his comprehensive work on crew protection. The citation specifically mentioned his device to protect gunners from wind blast, his electrically heated clothing and gloves, and boots and hand warmers, his casualty bags for wounded, and his wind and fire-resistant face and neck protectors. The recognition came because the solutions were working. Frostbite cases had decreased. Flight efficiency had increased. Crews were surviving missions they would have lost to the cold just months earlier. The statistics told the story of transformation. In early 1943, cold injuries exceeded combat wounds as a cause of crew losses. By late 1943 and into 1944, the proportions had reversed. Hand injuries, which had accounted for more than half of all cold injuries through July 1943, declined sharply as better gloves and improved training reduced the need to handle frozen metal with bare skin. Face, neck, and ear injuries increased proportionally as the hand injury rate fell. But these injuries were less serious in terms of manpower losses. A man with frostbitten ears could return to duty in days or weeks. A man missing fingers was permanently disabled. German intelligence noticed the changes. Luftwaffe pilots who had grown accustomed to American formations, suffering from cold-related problems, began encountering a more effective enemy. Waist gunners who had once been slow and clumsy from frozen hands were now tracking targets with full dexterity. Ball turret gunners who had once been incapacitated by failed heating suits were now staying in the fight for entire missions. The Germans did not understand exactly what had changed. They observed the effects without knowing the causes. American defensive fire seemed more accurate. American formation seemed more disciplined. Bombers that might once have straggled from formation due to injured crew were now staying tight in the defensive box. Some of that improvement came from better fighter escort, as P-51 Mustangs arrived in theater. Some came from improved tactics learned through bloody experience, but some of it came from crews that were simply more effective because they were not fighting Frostbite at the same time they were fighting the Luftwaffe. A gunner with fully functional hands could track a target smoothly. A gunner with numb fingers could not. A crew with all positions manned by alert, warm airmen could maintain proper defensive coverage. A crew with Frostbite casualties could not, but the cost of learning those lessons had been measured in fingers and toes and permanent disability. The first generation of 8th Air Force crews had served as unwilling test subjects, discovered through their own frozen flesh what worked and what failed at 30,000 feet. Lieutenant John Luckadoo flew B-17s with the 100th Bomb Group, the unit that became known as the Bloody Hundredth because of its staggering casualty rate. The group suffered losses so severe that newer crews sometimes believed the unit was cursed. Other bomber groups avoided flying near the 100th in formation, convinced that their bad luck was contagious. The reality was simpler and more tragic. The 100th was not cursed. They were simply assigned to some of the most dangerous missions during the worst period of the air war. They flew deep penetration raids into Germany before long-range fighter escort was available. They hit heavily defended targets while the Luftwaffe was at peak strength. They paid the price for strategic decisions made far above their pay grade. Luckadoo completed his 25 required combat missions between June 1943 and February 1944, one of the few men in his unit to do so. He flew through the worst period of the air war over Europe, when the 8th Air Force was fighting without adequate fighter escort, when bomber losses were so high that statistically a man could not expect to survive his tour. Decades later, when Luckadoo was over 100 years old, and the last surviving pilot from the original Bloody Hundredth, he spoke about those days to audiences who could barely imagine what he had experienced. Crew members experienced fighting at an altitude of 25,000 feet, he said. They withstood temperatures of minus 40 degrees Fahrenheit and survived. On oxygen above 10,000 feet due to unpressurized cabins. Prayers and luck accompanied the flyers on every mission. Luckadoo described the 4 challenges that defined every mission: fighter's flak, frostbite, fear. The alliteration captured the reality of aerial combat. German defenders were only part of the danger. The environment itself was trying to kill them. He recalled his own experience with the cold. My foot froze to a control pedal, he said. I had to land with my heels. I could not even apply the brakes. Temperatures were minus 50 to 60 degrees below zero. The 8th Air Force flew from 40 bomber bases and 15 fighter bases scattered across East Anglia, the rural agricultural region northeast of London. While the Royal Air Force bombed at night, the Americans flew the more dangerous daylight mission. Initially, crews were required to complete 25 missions to be eligible for rotation home. Airmen had approximately 1 in 3 odds of reaching that number during 1942 and 1943. 2 out of every 3 men would be killed, severely wounded, or captured before completing their tours. By the war's end, the 8th Air Force had suffered over 47,000 casualties, with more than 26,000 killed. The death toll exceeded that of the United States Marine Corps for the entire Pacific War. The frostbite epidemic was one component of that larger catastrophe, a preventable component. Men died and suffered permanent injuries because equipment failed, because training was inadequate, because no one had anticipated how badly the cold would affect operation. The training programs in the United States had not prepared crews for the reality of high-altitude combat in European winter conditions. Men trained in Texas and Arizona, where temperatures rarely dropped below freezing, even in winter. They practiced at altitudes where cold was uncomfortable but not dangerous. They learned to use their equipment in controlled environments where nothing went wrong. Then they arrived in England and flew their first missions into sky, where temperatures reached 50 and 60 degrees below zero, where the equipment they had trained on failed under conditions it had never been designed for, where everything they thought they knew about surviving at altitude proved inadequate. Some crews received supplementary training in England, but the 8th Air Force was desperate for replacements. Men were rushed into combat as quickly as possible. The training gap between what they learned stateside and what they needed to know in combat was filled by experience, and experience was paid for in blood and frozen flesh. The lessons learned in the frozen skies over Germany shaped military aviation for generations afterward. When the Boeing B-29 Superfortress entered service again, Japan in 1944, it featured fully pressurized crew compartments. The crew did not need electrically heated suits because the cabin maintained survivable temperatures at altitude. The gun turrets were remotely controlled for inside the pressurized cabin, eliminating the need for gunners to sit exposed in the slipstream. The B-29 represented a fundamentally different approach to high-altitude combat. Instead of trying to protect humans against an inhospitable environment, it eliminated their exposure to that environment entirely. The crew flew in shirt-sleeve comfort, while their aircraft operated at altitudes that would freeze an unprotected man in minutes. This design philosophy persisted into the jet age and beyond. Modern military aircraft feature pressurized, climate-controlled cockpits. Fighter pilots wear flight suits designed primarily for G-force protection and emergency ejection, not for survival in Arctic temperatures. The hard lessons of 1943 and 1944 had taught aircraft designers a fundamental truth. Human beings cannot reliably survive extreme cold, no matter how much protective equipment they wear. Better to engineer the cold out of the equation entirely. Every subsequent generation of military aircraft has followed this principle. Modern bombers and fighters maintain comfortable temperatures regardless of altitude or external conditions. Pilots face many dangers, but freezing to death is not among them. The 8th Air Force bought that safety with blood and frozen flesh over the skies of Germany. The engineering changes also reflected a broader shift in how the military thought about human factors in combat equipment. Before the Frostbite crisis, equipment designers often treated human limitations as problems for users to overcome through training and discipline. If the heating suit failed, train the crews to operate without it. If the gloves were too bulky, train the crews to clear jams while wearing them anyway. The frostbite epidemic demonstrated the bankruptcy of this approach. No amount of training could enable human fingers to function at 60 degrees below zero. No amount of discipline could prevent flesh from freezing on contact with sub-zero metal. The human body had physical limits that could not be overcome through willpower. After the war, military equipment design increasingly incorporated human factors engineering from the start. Designers asked not just whether equipment would function, but whether humans could function while using it. Colonel Malcolm Grow continued his distinguished career after the war. When the United States Air Force became an independent service in 1947, the new Air Force, medical service needed leadership from someone who understood both aviation and combat medicine. On July 1st, 1949, Malcolm Grow became the first Surgeon General of the United States Air Force. He had helped create the service he now led. His work on crew protection during the war had saved countless lives and established principles that still guide aerospace medicine. Grow retired from the Air Force on December 1st, 1949, after more than 31 years in uniform. He had served in 2 world wars. He had worn the uniforms of both Imperial Russia and the United States. He had pioneered the field of aviation medicine. He died on October 20th, 1960, at the age of 72, at the Air Force Hospital at Andrews Air Force Base. He was buried at Arlington National Cemetery. 2 years later, the Malcolm Grow Medical Center at Joint Base Andrews was named. In his honor, a permanent reminder of his contributions to military medicine. John Luckadoo, the last surviving pilot of the Bloody Hundredth, died on September 1st, 2025, at age 103. He had spent his final years telling the stories of the men who flew with him, making sure the world remembered what they had endured. He served as a technical consultant for the 2024 series Masters of the Air, ensuring that a new generation would understand what his generation had faced. The men who froze in the skies over Germany are gone now, the waist gunners and ball turret operators who endured minus 50-degree cold for hours while fighting for their lives, the tail gunners and radio operators who suffered frostbite despite wearing every piece of protective gear the Army could provide. Their generation has passed into history, but the experience of those frozen airmen shaped the world they left behind. Every pressurized cockpit, every climate-controlled crew station, every piece of cold-weather protective equipment used by modern aviators, all of it traces back to the failures and solutions of 1943. The frostbite epidemic was a preventable tragedy that became a forcing function for innovation. Men suffered and died because equipment was inadequate. Their suffering drove the development of equipment that was adequate. That is often how military technology advances, not through abstract research in comfortable laboratories, not through theoretical analysis by engineers who have never seen combat, but through the urgent, desperate need to solve problems that are killing people right now, today, this mission, this hour. The pressure of combat accelerates innovation in ways that peacetime never can. Failure means death. Death motivates change. Change saves the next crew. The 8th Air Force lost more men to frostbite than to enemy fire in the early months of the bombing campaign. That statistic should have been impossible. It became possible because the people designing equipment had never experienced what their equipment would face. By late 1944, the problem was largely solved. Better suits with parallel wiring, enclosed waist gun windows, improved gloves and protective equipment, systematic training on cold weather operations. Frostbite epidemic been reduced from a crisis to a manageable challenge. But the price of that solution was paid by the men who flew before the solutions arrived. The crews of 1942 and 1943. The men who discovered through their own frozen fingers what worked and what did not work at 30,000 feet. Their sacrifice deserves to be remembered, not as a story of failure, but as a story of adaptation and learning under the worst possible conditions. They faced fighters, they faced flak, they faced frostbite, they faced fear, and somehow enough of them survived to teach the lessons that would save those who came after. That is how innovation actually happens in war, not through committees and specifications and procurement processes, but through sergeants and surgeons who see problems, find solutions, and refuse to accept that good men must keep dying from preventable causes. Colonel Malcolm Gross saw the problem. He documented it. He analyzed it. He developed solutions. He pushed those solutions through a bureaucracy that moved too slowly while men were losing fingers and toes. He saved lives that would otherwise have been lost to the cold. His name is on a hospital now, but his real monument is every pressurized cockpit, every climate-controlled cruise station, every piece of protective equipment that keeps modern aviators safe from the killing cold of high altitude. The men of the 8th Air Force bought that safety with their suffering. The waist gunners with their frozen hands, the ball turret operators with their dead heating suits, the tail gunners with their frostbitten ears. They were test subjects in an experiment they never agreed to participate in. They discovered the limits of human endurance at minus 60 degrees. They paid the price so that no one would have to pay it again. We should not forget what they endured